Hi, good day Dr. Samsol and everyone. Today, we would like to present our project report for the subject static equipment. So here are the group members, me, Praveen, and with me, Jengda, Harith Kumar, and Vimalan. So let's hop into the question 1. This is the question 1. A. Using the suitable thermodynamic property method, determine the heat duty of the heater in kilowatt. So after the simulation, the answer we obtained is 19.9416 kilowatt. So here in figure 1, we can see the results of heater. Heat duty, after we changing the unit into kilowatt, we observe the answer we obtained is 19.9416. Along with heat duty, we can also observe the outlet temperature 148.889 Celsius, outlet pressure 6.55002 bar, vapor fraction 0.435477, as well as other results for net duty, first liquid total liquid, pressure drop correlation parameter, and also pressure drop.
For part B, simulate the separation process using a flash column. Determine the products of the flash column and fill in the following table 1. Now we are going to go through the table 1A, mass flow, kg per hour for flash, and the second one is for table 1B, composition, mole fraction for flash. Now we are going to look up figure 2, steam result for the flash mass flow. And the third figure shows steam result of flash in mole fraction.
Okay, now let's look at the question C. Simulate the separation process using the STWU column. Assume the following. A. Condenser and reboiler pressure are 98 psia. B. Condenser specifications is partial condenser with vapor and liquid distillate of 0.7. So both of these we will do as an input of the DSTWU column. Right. C requires separation specification LK in bottoms is 0.01 and HK in distillate is 0.99. So this is the specification we are going to look at. Is it meet the requirement and when we get the results? So fill in the following table too. So first of all, components of LK in bottoms and component of HK in distillate. So to get LK in bottoms, we need to find the lightest key in remains in the bottom. So we refer to the boiling point. Also, we can refer to the molecular weight to see which are the lightest component, which means it is more likely to become vapor early, and which is the heaviest component, which will remains as liquid. Right? So in the component remains at the bottoms. The most heavy is most light is nitrogen and remains in distillate. Most heavy is propane. So the reflux ratio is 337.233. This is overly too high, right? So this means bad, means they will start at there. It's not efficiency. So this is not practical in the real situation. Right? This is a bad simulation result. So next is minimum number of trays, 82, actual number of trays, 163, and optimum fit stage, 83. We get all these by run up the results. Okay, now this is the reference that we get our result. Figure 4 get result from the STWU, Figure 5 get stream results from the STWU, Figure 6 shows the boiling point of all components. That's all for me.
Hello, my name is Harith Kumar. My matrix number is TH23014. Today, now I'm going to explain about the part D and E. Okay, for the first part, which is the required separation cannot be achieved. as per given the conditions. The specified requirement for the mole fraction of the light key in the bottom is 0.01 and the heavy key HK in the distal is 0.99. However, the obtained results shows values lower than the rate of target, making it difficult to meet the exact requirements. Considering the mole fractions in the fluid, such as nitrogen and propane, it is mathematically impossible to achieve a larger mole fraction from the smaller one under the current setup. This indicates the separation efficiency need further optimization. For the last part, which is completing the labeling of the oil stream with the temperature, pressure, and mass flow rate, the labeling of the oil stream in the process flow diagram includes their respective temperature, pressure, and mass flow rates. Each stream has been identified based on its role in the system, such as the feed, vapor, liquid, distal, and bottoms. These parameters provide a critical insight into the operational condition at various points in the process, ensuring the proper tracking and analysis of the material flows through the heater, flash separator, and DSTW column. Accurate labeling helps to evaluate the system's performance and guides any necessary adjustments so that the process will be successfully on.